Hello dear students, this is the second class of motion. In this class, our topics are number 1, scalar and vector quantity, number 2, distance and displacement. So let us discuss scalar and vector quantity first. Scalar quantity, it is the physical quantity having only magnitude but no direction. Example, distance, speed. Vector quantity, it is the physical quantity having magnitude and direction both. Example, displacement, velocity. What is magnitude? Magnitude means numerical digit plus its unit. For example, if I write 5 meter, that is magnitude, having numerical digit and unit. When I write 3 degree centigrade, it is magnitude, having numerical digit and unit. So, what are scalar quantities? The quantities having only magnitude. What are vector quantities? The quantities having magnitude and direction. Let us discuss an example. Time. What do you think? What is time? It is a scalar quantity or vector. We always write or say time as 7 p.m., 8 p.m., 6 a.m., etc. etc. What is 7 p.m.? It is magnitude, and the quantity which having only magnitude is called scalar. So what is time? What do you think? Time is scalar quantity. Let us discuss another example, temperature. What is temperature? Scalar or vector? We always use temperature as 30 degrees centigrade, 40 degrees centigrade, 50, etc. etc. So what is 30 degrees centigrade? It is a magnitude, and the quantity which having only magnitude is called scalar quantity. Let's discuss about force. What is force? What is the basic definition of force? It is either push or pull. So push or pull itself having direction. So what is force? It is a vector quantity. So I think you have been cleared about scalar quantities and vector quantities. Now we will discuss about distance and displacement. These two quantities play an important role in motion. Let us see what is distance and what is displacement. So first, distance, the actual path or length traveled by an object, or we can say path length traveled by an object. Displacement, the shortest distance between initial point and final point is called displacement. Let us suppose we have a girl at position A at rest. Now she starts moving towards B. Suppose the distance from A to B is 5 meter. From B she comes to C, and the distance from B to C is 2 meter. What about the change in position of a girl? Girl changes from A to B and B to C. In this case, what is the total distance covered by the girl? Total distance covered by the girl is 7 meter. From A to B 5 and from B to C 2 meter. So 5 plus 2, 7 meter. What is the displacement of the girl? Displacement is the minimum distance between initial position and final position. So this is the minimum distance, AC. So what is the displacement of the girl? AC. Now, let us take an example where distance is equal to displacement. When the object is moving in a straight line, in this case, distance is always equal to displacement. Let us suppose we have a boy at position A at rest. Now he starts moving towards B. Suppose the distance between A to B is 5 meter. In this case, what is the distance covered by the boy? 5 meter. in this case, what is the displacement of the boy? Again, it is 5 meter because boy is going straight line. So when the object is moving in a straight line, in that case, distance is always equal to displacement. I think distance and displacement has been clear for you. We have some difference between distance and displacement. Let's see. Distance. The actual path or length traveled by an object. Displacement, the shortest distance between initial and final position. Distance, scalar quantity. Displacement, vector quantity. Distance, always positive. Displacement, positive, negative or 0. So, in today's class, we discussed two things. One, scalar and vector, and second, distance and displacement. Thank you.